Most people hear that the nervous system runs on electricity and picture something like a wire with electrons moving from point A to point B. But that mental model doesn't really work for neurons, which is why the idea never quite sticks. Neurons, which are the cells that make up nerves, which make up the nervous system, don't move electrons around. They move around ions, like sodium and potassium mostly, in and out of the cell through channels in that cell membrane. That ion movement changes the voltage across the membrane, and when it crosses a certain threshold, it triggers the next stretch of membranes to do the same thing, and the next, kind of propagating the signal. That's essentially an action potential, and instead of electricity flowing down a wire, it's kind of this wave of voltage change traveling down a cell. It kind of gets clearer if you go back to fundamentally what electricity actually is. Electricity isn't fundamentally about electrons specifically. It's just about the movement of any charged particle creating current and a voltage difference. Electrons in a copper wire are one version of that, but sodium and potassium ions crossing a neuron's membrane are just another version of the exact same underlying principle, just moving through a fluid instead of metal, and much slower. Once you kind of widen that definition to charge moving equals electricity, the nervous system stops being this weird biological exception and becomes just another system running on the same physics as everything else that's electrical. The nervous system isn't electrical in some loose metaphorical sense. It's electrical in the literal textbook definition. We just kind of built our intuition for electricity around wires instead of membranes.